In our world today, modern scientists work on the boundaries of the observable universe, where everything is unknown. That is why every piece of knowledge leads to a path of uncertainty or mind-boggling discoveries. And nothing is more uncertain or mind-boggling than paradoxes.
Paradoxes has baffled the minds of different scientists and physicists around the world, at the same time has contradicted what we know about our universe. One of the biggest and most enlightening paradox we have today, which unravels the field of quantum mechanics and general relativity, is the black hole information paradox.
Now, to further understand the topic, we need to know the meaning of information and quantum information. Information that we know and talk about is the things that we see through the naked eye. For example, I have a banana here. Looking at the banana, I can see that it is yellow, rough, and elongated.
But physicists, on the other hand, see the banana in a different way. Physicists are more concerned with the banana's quantum information, wherein quantum information talks about the properties that make up the banana. As the physicist sees the banana, he automatically recognizes the banana's velocity, spin, and position. Now, to further understand this topic, I have two practical examples for you. First, I have here a blender and a fruit. Even though the fruit gets blended, its quantum information is never permanently deleted. In other words, even though we can say that the fruit is seen as shredded, the particle that fruit holds is still there. That is why we can say its quantum information is retained.
For the second experiment, we have a vacuum cleaner.
Assuming that the paper shreds are the information, the vacuum cleaner being the black hole, and the suction will be represented as the force of gravity. Now, as you observe that the shredded pieces of paper vanish out of sight, but we do know that the shredded paper went inside that vacuum. We just don't know where. Same goes for the information we do not fully understand just yet. Where does exactly information go?
And now that we have done that, how about a real simulation on how information goes inside a black hole?
Now, as you can see that the information suddenly disappeared. It's like it vanished forever, and from the looks of the circumstances, we do not know where it went. Is it in the black hole, or has it gone somewhere else? Well, with these theories, we can suggest that as the black hole's masses increases, the surface of event horizon increases as well. So it's possible that once the black hole swallows an object, the black hole grows larger enough to retain the object's quantum information.
Now, we know how information is conserved, but what are the things that make it a paradox? Well, there is this thing called the Hawking's radiation, wherein it contradicts what we know about the law of conservation of information.
This was discovered by Stephen Hawking in 1974, wherein he stated that a black hole evaporates over a long period of time. Hawking also stated that due to this evaporation, the black hole loses its mass due to shredding of particles away from the event horizon. Well, we talked about almost everything there is to this paradox, but the most interesting and most mind-bending theory that comes with this paradox is now exploring the idea that the 2D surface of the event horizon can store quantum information. This principle states that the very boundary of our observable universe is also a 2D surface encoded with information about real 3D objects.
Now, if I were to put this topic into a beneficial or practical use, I can say that this topic will be relevant to the advancement of 3D printers.
This prototype can be used in exactly printing the body parts of people who may have lost any legs in tragedies, sickness, and many more.
It takes a leap of faith to discover something new. That is why it is always up to us to be brave enough to take that leap for science and beyond.